Good morning, and welcome again to Someone is Wrong on the Internet. A viewer by the name of Practice Righteousness commented on my last video, saying that if the Earth really orbits the Sun, that we should be able to see the stars seeming to change position due to the Earth's orbital motion. The argument goes like this. If the star Polaris is above the North Pole now, then in 6 months the Earth will be on the other side of its orbit, 186 million miles, or 300 billion kilometers, away, and Polaris will seem to have shifted its position away from the North Pole by that same distance. But Polaris is always seen near the North Pole, so therefore the Earth cannot orbit the Sun. This is not a new argument. Back when Copernicus first proposed that the Earth orbits the Sun, skeptics of the idea brought up this very same objection. The effect is called stellar parallax, and it works not just for the North Star, but for every star. If the Earth goes around the Sun in an elliptical orbit, then we should see the stars tracing out ellipses on the sky throughout the year, and we don't see that. The counterargument was that the further away a star was, the smaller the angles involved would be, and maybe the stars were just so far away that we couldn't see the difference in angle. The problem was that no one knew how far away the stars were, and in order for the angles to be invisible, the stars would have to be incredibly far away, hundreds of thousands of times as far away as the Sun is from the Earth. And so the controversy went on for hundreds of years, from the time of Copernicus until the year 1838, when the astronomer Friedrich Bessel observed and measured stellar parallax for the first time in history. Traditionally, parallax is measured as half the angle between one side of the Earth's orbit and the other, like so. The human eye can resolve angles down to about 1 minute of arc, or a 60th of a degree, and modern telescopes can resolve angles smaller than a second of arc, or a 60th of a minute of arc, but it turns out that the angles involved in stellar parallax are all smaller than a second of arc. The basic unit for measuring distance to the stars, the parsec, is short for parallax second, and it's defined as the distance a star has to be away from the Earth in order for its parallax angle to be 1 second of arc. In layman's terms, it's a little more than 3 light years, or about 200,000 times as far as the Sun is from the Earth. Bessel measured the parallax of the star 61 Cygni to be 3/10 of a second of arc, establishing its distance from the Earth to be about 3 parsecs. That's 600,000 times as far as the Sun is from the Earth, and 61 Cygni is nearby as stars go. Nowadays, the parallax of stars is measured routinely using ground-based and space-based telescopes in order to determine their distances, and it's known that even the closest star is more than a parsec away. Polaris, for example, has a parallax of 0.0075 arcseconds, and is therefore 100 parsecs away. That's 20 million times the distance between the Earth and Sun. This almost unfathomable distance is the reason we can't see the parallax with our naked eyes. The sideways swing of the Earth in its orbit is minuscule in comparison to the distances to the stars, and the angles involved are therefore minuscule as well. So in answer to Practice Righteousness, the fact that stellar parallax does exist, and that it's so small in effect, demonstrates that the Earth does in fact orbit the Sun, and that the distances to all but the closest stars are millions of times larger than the distance between the Earth and the Sun.